Hello, my name is Piotr Lazarek and I'm a student at Dulwich College in London. First of all, I want to thank you for allowing me to showcase my work to you regardless of the current situation. In this short video, I would like to tell you a story about the project which has changed my life and taught me much more than I initially anticipated. My adventure began 3 years ago. Since then, I have been developing scientific projects in the area of environmental engineering. Thanks to media attention around my previous project, I had the opportunity to meet Bertrand Piccard. He is a famous scientist and adventurer who designed a solar-powered airplane and flew it around the world with no fuel at all, using only renewable energy sources. His story inspired me to create my own solar-powered airplane. Back then I thought that it couldn't be that hard. Obviously I was wrong, and after a while I got stuck because I couldn't find any devices in the consumer market which would efficiently deal with solar power management issues. I did some research and it appeared that many more students have tried to develop such technologies, but they have faced the same problems as I did and have since given up on developing their own solar-powered airplanes. So, sensing an opportunity, I decided to design and create a battery management system for solar-powered UAVs. So, generally speaking, a device which would significantly simplify the prototyping process of solar-powered airplanes. First of all, I did a lot of research about drones and especially their recent rapid growth in production. After a while, I realized that one of the main reasons for such rapid growth is this little commercial autopilot. Owing to it, the process of drone prototyping comes down to literally connecting wires and programming in the visual environment, which allows students all around the world to develop their own drone-related projects and hence contribute to the growth of the whole industry. I realized that the company producing these autopilots had done something very similar to what I was trying to achieve, and this is why I contacted them about my idea. They were so interested in it that they sent me a free sample of their product and invited me to speak with their CTO at a conference in China. Obviously, I wanted to impress them, so I decided to create the first prototype before the conference. At the beginning, I spent weeks reading technical documentations in order to choose the most suitable modules for my device. Right after, I started designing the printed circuit board in the Altium Designer. It was probably the most challenging part of the whole project. Sometimes I thought that I could have done something better or that I had done something wrong, so I repeatedly started from scratch. Nevertheless, after some sleepless nights, I finally came up with a complete design. The next step was to manufacture the first prototype. I bought all of the 180 necessary components and outsourced the PCB production to a Chinese company. I soldered all components using solder paste and a convection oven. The result was a fully functioning prototype, but it definitely wasn't the end of the whole process. I still had to test its performance. Testing wasn't as easy as I initially thought it would be. As you can see in the picture, I had to create the whole test setup that simulates the behavior of solar cells. The input current and voltage as well as output current and voltage were monitored continuously for about a week. These are the processed results. As you can see, efficiency increases with current as well as with battery voltage. Overall, the efficiency of the device ranges between 88 and 98%, which clearly proves that the prototype works as it was supposed to. My device provides functionalities of at least 3 separate devices. The maximum power point tracker ensures that the device will reach the highest possible efficiency regardless of circumstances. The Li-Pol and Li-ion battery charging unit is responsible for charging the battery in a safe and effective way. The battery balancer module reduces charge disproportions across each cell and ensures that the battery maintains constant maximum capacity and doesn't overcharge. The Coulomb counter module saves information about charging and discharging current in order to calculate battery charge status. The device is extremely small and lightweight. It is about 5 cm long, 3 cm wide, and it weighs about 3.5 paper sheets. It has been designed to withstand charging power up to around 150 watts, with its efficiency reaching about 95%. The production cost of such a device in mass production is estimated to be approximately 50 to 70 pounds. It took me about half a year to create the first prototype of my device. Do you know how long it took me to create this solar-powered airplane with it? About 2 weeks, and this is precisely what I was trying to achieve with my project. Thanks to my device, the prototyping process of this airplane was significantly simplified. Thank you very much for your attention.